Poor air quality can mask increasing temperatures caused by climate change. Researchers have found during the 20th century, temperatures rose by almost 1 degree Fahrenheit everywhere in the U.S. except for the southeast, where temperatures actually decreased slightly until the 1980s. But in the 1990s, temperatures in the southeast started rising, and a new study found that it may have been because the air quality in the region improved, causing the warming hole to disappear. Warming holes are regions where the effects of climate change are being muted by the high concentrations of aerosols in the atmosphere. Airborne aerosols are tiny particles of dust, soot from wood burning, coal and oil combustion, or sulfates from gases emitted from factories and car exhaust. These aerosols can decrease temperature by dimming sunlight at Earth's surface and by increasing the number and lifetimes of clouds, which reflect sunlight back into space. A new study, led by a researcher at NASA's Jet Propulsion Laboratory in Pasadena, California, found evidence that a significant improvement in air quality in the region may have contributed to the disappearance of the southeast's warming hole after about 1990. This study also suggests that other polluted regions outside the U.S., such as China and India, may experience the same phenomenon after the warming hole disappeared. Different studies proposed possible cause changes in cloud cover, precipitation, or in the amount of aerosols produced by air pollution. In 2006, the U.S. Environmental Protection Agency (EPA) began implementing a more stringent cap on the concentration of aerosol particles smaller than 1/10,000th of an inch in diameter. And to comply with the regulation, many U.S. power utilities and industrial companies began reducing their use of coal and installing filters to reduce emissions. A similar temperature change pattern occurred in Europe in the 1980s after new regulations led to improved air quality there. Because these reduced aerosol particle concentrations let more sunlight reach the Earth's surface, the researchers suggested that the improvements in U.S. air quality could also be responsible for the temperature increase in the southeast. To test this idea, the researchers used 3 surface temperatures data sets. They also used aerosol data from 2 satellite instruments on NASA's Terra satellite and the Calypso satellite, a joint mission between NASA and the French space agency CNES. The data showed that between 2000 and 2015, summertime temperatures in the southeastern U.S. increased by about 1.5 degrees Fahrenheit (0.75 degrees Celsius), which is significantly faster than the increase in the continental U.S. during the 20th century. At the same time that this temperature increase occurred, summertime aerosols decreased overall by about 20%, which coincided with the implementation of the new EPA standards. To determine how much of the temperature change was caused by change in aerosols, the researchers used a model that simulates how the sun's energy travels through Earth's atmosphere. Using the satellite data as inputs, the increase in sunlight shown in the models matches well with daily measurements taken at a National Oceanic and Atmospheric Administration (NOAA) solar radiation monitoring station, suggesting that the decrease in aerosols is a plausible explanation for most of the disappearance of the warming hole. The leader of the research, Dr. Mike Tosca, says that the link between aerosols and clouds could also play a role, and the next step in the research would be to run another climate model that takes into account clouds and the aerosols' effect on them. The team also wants to apply this method to other areas with high air pollution levels such as China and India, as these areas might have warming holes too. If pollution in these areas is reduced, they may experience a sudden increase in temperature as well. Overall, the goal is to more accurately predict what will happen to our planet, Dr. Tosca says. This type of observation-based research gives us better models give us better forecasts, and better forecasts enable better policy.